Morning, guys. So the first lesson back is going to be exponential functions. Before I get into that, just a couple housekeeping things. Make sure you guys are checking Google Classroom, checking your email as much as possible. That's the best way to reach me, to be honest with you. And then also, if you have not taken Hawks test number 2, you need to make sure you get that done. I will send you the password. We are trusting that you will use good ethics, good morals to take the test honestly. After the 3 tries with that password, I will change it, and then I will give you a different password. So please make sure you're getting that done. That's really all I have. This is how it's usually going to work. We do a video, and then we'll do a couple questions within the video, and I'll have you guys submit those on Classroom, and then there'll be an assignment, usually a Hawks assignment. So today's exponential function, 7.1. Again, we're going to graph it, talk about the properties of it. The big thing that I want you guys to take away from this is we've done exponential functions before in Algebra 2. However, this is a nice recap. If the base is greater than 1, that's going to be growth. If the base is between 0 and 1, that's going to be decay. And that just helps you get the general shape. So growth is going to look like this. Decay is going to look like this. And you just need to know those general shapes. That'll help you with the Hawks assignment. So the first thing I'm going to have you guys do is we're going to do this on together. But if you're at home, have a graphing calculator. I would like for you to use a graphing calculator. If not, you can use Desmos. We're going to take this equation, fill in these numbers, and graph it. So if I did to the negative second, I would get 1/4. To the negative first, I would get 1/2. To 0, anything to the 0 power is 1. Do not forget that. That's very important. Anything to the first is itself, and then anything would be 4. Notice the base is a 2, so this is going to be a growth equation. So your shape should start low and then curve up. And if we graph it, you should be able to see that as we go along. So that's what my graph looks like, and yours should be similar. Now we're going to talk about the y-intercept. Guys, most of the time the y-intercept is going to be 0, 1, and in this case it is. Just look at when x is 0. That'll give you the y-intercept. Your x-intercept, there is none because it doesn't cross the x-axis. Your domain, how far left to how far right. Right? We're going to have negative infinity to infinity, or you can say all real numbers. Your range is from bottom to top. It never hits 0, but it gets really close, and then it goes to positive infinity. Your asymptote, for most part, guys, this is almost always going to be y equals 0, unless there is a horizontal shift. And again, that line is right here. If you look at the graph, I'm making it right now. It's a line that it never crosses. In this case, if it's growth, it's going to be increasing the whole time. There is no decreasing on this one. So that's the first example. What I would like you guys to do, on a piece of paper, I want you to answer, you're going to graph it on a graphing calculator on Desmos, but I want you to answer the other questions. So that for these two, I want you to find the y-intercept, the x-intercept, asymptote, increasing, decreasing, and I want you to find domain and range. So on a piece of paper, I want you to do these 2 equations. Write down your answers. Sure, all work if you have to. With this one, it's kind of easy to look at the graph and tell, but I want you to do that. You are going to submit this. This is part of your assignment, so just keep that piece of paper handy. So those 2 problems right there. Moving on, the next one is going to be decay, because if you look at my base, it's 1/2, which is less than 1 but greater than 0. And if we graph it, we should get something like this. I can graph it again over here, so you can get the general shape. My y-intercept again is 0, 1. Again, guys, that's usually what it's going to be. It just kind of varies if I move it up or down, and we'll talk about transformations next. There is no x-intercept. Your domain is negative infinity to positive infinity. Your range is from 0 to infinity. We do not include 0. because there is an asymptote at 0. And then there is no increasing because it's decay. So what do you think we're doing the whole time? We are decreasing. This is an example of growth and decay. So those two right there. If you need to pause it, you can pause it at any time and just keep watching the video. So the general properties, just so you guys know, the domain usually is negative infinity to positive infinity. Your range is usually 0 to infinity unless we move it up or down. Increasing or decreasing depends on growth or decay. Your y-intercept is usually going to be 0, 1. Again, that depends on if we move it up or down. And the horizontal asymptote is usually going to be y equals 0. Guys, those are the general properties. Not always, but for most cases. Okay, next thing, transformations. We've done these before, guys. They're almost similar. The vertical shift is going to be your k. If I have a positive k, that means I'm going to go up. If I have a negative k, that means I'm going to go down. Horizontal shift is going to be your h up here. If it's a negative h, remember their line, I go right. If it's a positive h, I go left. So I'm going to say line right here. Reflection, if there's a negative in front of A, that's the x-axis. If there's a negative x, that is the y-axis. So you're looking at the negative and the exponent for the y-axis. Stretch is going to be if A is greater than 1, and compression is if A is less than 1, but greater than 0. And we've seen those examples before. This is usually a fraction, so just keep that in mind. And you guys have seen those before, but it is nice to recap them. So this one, what I want you to do, we're going to do this first one together. You can graph it, okay, and then you can graph the new equation, or you can just graph the new equation right here. The transformation, right, it should be right one. Now another question I want to ask is it growth or is it decay? Look at your base, it's a 2, so that means it's going to be growth. So your domain, guys, is going to be negative infinity to infinity. Now here's what I was talking about with transformations. It might change some things, it just kind of depends on what you're doing. So my range, did I move it up or down? No, so that actually doesn't end up changing. However, just be careful of that. We just talked about this. This is growth. Horizontal asymptote is still going to be at y equals 0. The last thing I want you to guys do, instead of confirming it, which you are going to do anyways because you're graphing it, is your y-intercept. So you can make a t-chart to find your y-intercept. Right, if x is 0, what is y going to be? So I plug it into my equation. I get 2 to the negative first, which is 1/2. So my y-intercept is 0, 1/2. Just be careful of that. That one is different now. So the next slide, what I want you guys to do is I'd like for you to do this problem right here. So on your piece of paper, you're going to answer these questions. You can confirm it, and then I also want you to find the y-intercept. Again, this is part of your assignment participation grade, so you are going to submit this. I need to see work, so I need you to write down the problem and then answer these questions. So this should be like 1, 2, 3, 4, 5 questions on this one. Okay, the last thing that is going to be on the Hawks is elementary exponential equations. I don't think this is hard. The big thing is we're going to rewrite it with powers of the same number. So you're looking for a base that's pretty small, usually. In this case, 2, if I do a right here, is going to be my base. Can I think of 2 to a power that would give me 32? In this case, 2 to the 5th is 32, so I just rewrote it. Now that they have the same base, the 2, I can get rid of it and just say x equals 5. And you have solved the equation. That's how a lot of these work, guys. Just be careful and make sure you're using numbers. The hardest one is probably D, and I'll go over that one. But this next one, if I rewrote it, 2 to the x minus 4, I can rewrite 16 as a base power of 2. This one's to the fourth. So I get x minus 4 equals 4. You're going to solve for x just like you normally would. And you get x equals 8. Next one, I might have to rewrite both of them. It just depends on the problem. I can rewrite 4 as 2 to the second. Don't forget your exponent. I can rewrite 8 as 2 to the third. Again, don't forget your exponent. Now this one's a little bit trickier because if I have a power to a power, yes, your base is going to disappear, but you have to multiply, and that means distribute. So I'm going to end up getting 4x minus 2 equals 3x plus 9. So then I would add my 2 over. I get 4x equals 3x plus 11. Subtract 3x. I get x equals 11. Again, just be careful of that. If you see a fraction, usually you're going to pick the one that has the smallest denominator. Look at this. Can I rewrite 4 as a power of 2? The answer is yes. So I'm going to have this one still. I can rewrite this as 1/2 to the second raised to the fifth. Again, you have a power to a power, so what do you have to do? You have to multiply, and then you would solve it. End up getting x equals 2. So the last thing I want you guys to do would be these 4 problems right here. I will post notes to this on Classroom as well with this video. So I'm going to ask that you do 6 questions and submit that to Google Classroom. You can take a picture on your phone or your laptop and submit it, and that'll be proof that you've done it. I also want to make sure you watch the videos, and I can see that online, so make sure you watch them. And then the last thing you guys are going to do, your homework is 5.1 Hawks. Alright, if you have any questions, send me an email, okay? Have a good day, guys.